Hey there, welcome to a video discussing more about graphs of quadratic functions. This is technically under section 4.10. Actually, no, sorry, I take it back, 4.9 in the textbook. But we're going to still do it anyway because it's still in line with all this other stuff we've done with graphing. So we're going to review graphs of quadratic functions in standard form. So this right here is in standard form. Remember, standard form is y equals ax squared plus bx plus c. Remember, there's also a formula we would use to find the x coordinate of the vertex if you have an equation in standard form. So here's what we're going to do. We'll do negative 2 over 2 times 1. Negative 2 over 2 is negative 1. You're going to plug it back into the equation. Get the y coordinate of the vertex, which you guys should know how to do. And that's going to be negative 4, which is right there. We'll make a little table, and we'll plug in a couple more x coordinates. We'll do 1 on each side of the vertex, so like 0 for x, negative 2 for x, because negative 1 was the x coordinate of our vertex. Plug 0, you get negative 3. And you should get the same y value for negative 2 because of the sense of symmetry, but if you were to plug negative 2 into the equation right here, you would get negative 3. And there's our graph. So pretty simple, not too hard. Now let's do a little twist to it. Again, we have something in standard form, but it's an inequality. So again, negative b over 2a, find x coordinate of the vertex, plugging it in to get the y coordinate of the vertex, and I believe we can get negative 9. Yes, we would get negative 9. So you have negative 2, negative 9 is your vertex, which is way down here. I'm going to plug in a couple of values, one to the left and one to the right of negative 2. If I plug in negative 1, I believe I get negative 8, and you will get negative 8 again. And now, because it's no equal sign, just a less than or greater than, you can do a dashed parabola. And because it's greater, we're going to shade above it. And if we do it for the test point, like say 0, 0, 0 for y, 0 for x. And we're going to notice that it's true. 0 is greater than negative 5. So 0, 0 is included in our shaded region, so we feel good about it. Always going to do a test point to make sure you've interpreted the inequality in the shaded region correctly. So greater than go above, less than goes below. In fact, there are 4 scenarios. So if y is greater than x squared, y is less than x squared, y is greater than negative x squared, or y is less than negative x squared. So here, obviously, our a value is positive. Here, our a value is negative, a is a coefficient of x squared. And I could have done equal signs with the inequalities, I didn't feel like it, but here's y equals x squared, but if it's greater, you go above. Here's x squared again, if it's less, you go outside or below. Or if your parabola is facing down, and it's greater, I guess it is outside in this case, but it's above. Or if you have this, and it's less than, it's inside, or in this case below. But best the thing was above or below. If you do think it was inside or outside, then you do have to look at these 4 scenarios. Obviously, this is inside, and that's outside. That's outside. That's inside. But personally, I like to think of greater than as above, or less than as below. So it's a little more consistent. But if you do think it's inside or outside, then you do have to look at all these 4 scenarios. What a is positive or negative, and if, of course, if greater or less than. And always test points too, just to be sure. Just throw it back into the inequality, pick a point in the shaded region, see if it satisfies the inequality. So we'll do a couple more for practice. So in this case, this is intercept form. So our x-intercepts are going to be 3 and 5. The corner vertex, if you just use a little intuition, is going to be 4 because it's halfway between. And if you were to plug in 4 for x, with a negative on the outside, remember that. I think you get 1. So the parabola looks like this, and it's solid because there's an equal sign. And it's less than, so we're going to go below, or in this case, according to the scenario, your a is negative, and your less than, so you're inside. And you could test a point like, say, 4, -1. And you will get positive 1, so that's a true statement. Last example, -b over 2a, because it's standard form. You get 3. Four is 12 minus 36 plus 9. That one's a little nasty. It's -24. Yeah, I think you get -15 for that one. Let's make sure I did this one right. Yeah. Yeah. So it's kind of off to the graph a little bit, but that's okay. And I'll make a little table. Sometimes you don't have to go 1 away from the vertex. You can go several values away. Like if I go 0 for x, I know I get 9 because that's the y-intercept, which is way up here. And if I think about symmetry, I also get 6, 9, mainly because 6 and 0 are both 3 away from the vertex. It's going to be dashed. And it's less than the outside. It's like this scenario, less than with a positive. If you test a point like, say, 1, -1, sorry, I meant to say -1, or actually, let's do -1, 1. 1 for y, and 1 for x. Yeah, that's a true statement. That would work because 1 is less than 23. Yeah. So anyway, we'll practice in class as well as do some more word problems this week. Okay, that ends the video. Goodbye.